Programming is the backbone of the real world.
But for beginners, programming can feel overwhelming. Most of the time, it just looks like lines of code on a screen.
This is exactly why we built blocks of code.
Our goal is to turn programming from something abstract into something physical, visual, and interactive.
Hi, my name's Ansley, and I'm an electrical engineer, and I worked on the PCB design and mechanical development.
My name is Camila. I'm an electrical engineer, and I also work on the PCB design and power system.
My name is Jordan. I'm computer engineering, and I led the app development as well as the main firmware integration.
Hi, I'm Destiny, and I'm a computer engineering as well, and I worked towards the firmware and software integration.
The main goal of blocks of code is to make programming easier to understand for beginners by giving them something they can physically build with.
Our system is designed as a modular platform with up to 15 blocks that connect together to create a program sequence. As blocks are connected, the brain block identifies them, builds the configuration, and sends that information to our companion app in real time.
That means learners are not only building with physical blocks, but they are also seeing their logic appear live on the screen as they go.
This has a broader impact because it lowers the barrier to entry for younger learners and for students who struggle with traditional text-based coding environments.
Instead of memorizing syntax, they can focus on understanding logic, sequence conditions, and repetition in a much more intuitive way. By combining tactile interaction, visual feedback, and real-time validation, we make programming feel less intimidating and more accessible.
All 15 blocks in our system share a common hardware platform.
Each block uses an ESP32 ROM32, a TFT touch display, an LED matrix, and an LM38 base audio output. This common platform made the system easier to scale, manufacture, and more consistent across all block types.
The core of the system is the brain block. It acts as the I2C master and scans the connected blocks to determine the current program structure.
Each block acts as an I2C device with its own identity and configuration data, allowing the brain to reconstruct the full chain into a sequential program.
Once the brain has the configuration, it sends JSON packets over Wi-Fi through a TCP server to the desktop Flutter companion app.
That app displays the current program, checks whether the sequence is valid, and provides immediate feedback to the user.
This architecture lets us combine physical hardware interaction with live software validation, which is one of the key strengths for our system.
For our first demo, we start with basic output sequence. Here, we connect the brain block and 3 output blocks. Each output block can be configured to perform a different action, such as an LED output, individual notes, or actual sounds. Once configured, the brain executes the sequence, and the learner immediately sees the results.
Our second scenario demonstrates control flow using loops. Here we connect a loop block with a sequence of output actions. The loop and end loop blocks define a repeated section of the program, allowing learners to understand repetition without writing code. When we execute this chain, the output repeats automatically based on the program logic.
Next, we demonstrate conditional logic with physical interaction. In this scenario, we use an if block with a button-based condition. The system waits for the required input, and only after the button is pressed does it continue on to the next action. This helps learners understand that some actions only happen when a condition is true. Our final demo scenario shows one of the most important parts of the system, validation. Here, we intentionally create an invalid sequence, such as an if block without the proper supporting structure. The app immediately detects the issue and flags it in red. Instead of simply failing, the system gives the learner useful feedback about what is wrong.
That way, the student learns correct program structure before execution even begins.
Throughout the semester, we tested and refined our system, both technically and through user feedback.
On the technical side, we evaluated things like signal rise times, touch to output latency, configuration to app latency, and valid versus invalid configuration handlings.
We also use simulation and repeated execution testing to improve reliability in the executor and overall system behavior.
Just as importantly, we tested the system with real users. Watching kids interact with the blocks showed us what felt intuitive and what needed improvement.
Nice.
Yay!
Feedback from faculty and stakeholders also shaped our design.
For example, recommendations help guide major decisions like using ESP32 across all blocks, improving enclosure details, and making the interface more engaging through the TFT displays.
User feedback also suggested adding more songs, more visual personality, and more engaging block presentation.
That iterative process helped us improve not just the hardware and the software, but the full learning experience.
Blocks of Code version 3 brings together hardware, firmware, networking, and user design into one educational platform.
It transforms programming from something invisible and intimidating into something learners can build, see, and understand.
By combining modular hardware, real-time synchronization, and immediate validation, we created a system that is both technically strong and accessible to beginners.
Our next step is to continue expanding the platform and moving closer to real classroom deployment and curriculum integration. Thank you.